For question 13, we have a common base amplifier. And again, we have to draw the small signal equivalent circuit using the T model, compute the values of the small signal parameters, derive and calculate the values of the input resistance, output resistance, and the overall voltage gain. So let's start with part A. So remember that for the small signal model, we have to basically the capacitor becomes a short circuit here, and then the voltage VCC also goes directly to the ground, right? So the circuit that we end up having for part A, it would be just the base here. Then we have the small signal RE. Here is the emitter. Just remember that the base is grounded. And then here we have the capital RE. So this is the small RE. Here we have the current source, alpha IE. Then we have the collector resistance, and the load, RL, RC. And then our input is connected here. So it goes directly at the emitter. This is RS. This is VS. Okay. So those are the, let me just, so this is the small signal model. Now for the small signal values, we have to calculate IC, right? So we know it's beta IB, which is 90 times 20 microamperes. That's 1.8 milliamperes. So we can calculate GM. That's IC over VT, which is 0.0072 ampere per volt. And we can calculate the emitter resistance, which is alpha over GM, which is 0.98901 divided by 0.072. That's 13.73 ohms. Okay. Now C for the input resistance. So if we look at the circuit here, right, the input resistance is just, so because this one here is grounded, right, and this one here is grounded, so it's the resistance seen from this terminal, right? Then we have just RE, a small signal RE in parallel with RE, so it's RE in parallel with RE, which is equals to 13.55 ohms, which is almost RE, right? Because that's the smallest value on the parallel. So this is the value of RI. So I would say C and D at the same time. Now for the output resistance, if we look at the circuit here, is the resistance seen from this terminal. When this alpha E here is it's zero, there is no current there, so it goes to the ground, and that's approximately RC, which in our case, so RC is equals to 2K ohm. Okay. Now for the overall voltage gain, let's do it like in parts again. So for AV1, which is VI over VS, right? So for this one here, we have just R1 divided by R1 times RS, right? Because that's the same as before. And this gives us something around 0.1193. Okay. Now for AV2, then we have that it's alpha times RC RL divided by RE. Okay, so if we look at the V out here, remember that AV2 is V out over VI. So this is alpha. There's no phase inversion here, so there's no sign change, times RC parallel with RL divided by the small signal emitter resistance. And this one here, it's around 48 volt per volt. Okay, so the overall voltage gain, AV, is equals to 5.72. It's just 48 times 0.1193. Okay, so this is the solution for this problem.